Alright, so what is the molarity of a solution that contains 20.45 grams of sodium chloride, dissolved in 700 milliliters of solution? So I no idea how to do this, but I do know that it's molarity and it's a solution. So because it's a solution, I'm going to look at my solution formulas. So solution formulas, and the first one tells me I need to find molarity. Oh, okay. So I have molarity is equal to moles over liters. Well, that's pretty cool, except I'm not given moles, I'm given grams. And I'm not given liters, I'm given milliliters. So then I guess we have to find those. I'm going to start off with my grams. I have 20.45 grams. Well, it's pretty easy because I know what my substance is. It's sodium chloride. So I can just find the molar mass of sodium chloride. So I look at my periodic table and I look for sodium. Sodium is 23. And chlorine is 35. So 23 plus 35, 23 plus 35 equals 58. So I have a molar mass of 58. So I have 58. I'm going to put that at the bottom because it's 58 grams for every 1 mole. And I need to get moles. So I have 20.45 and I'm going to divide that by 58. That gives me 0.3526 moles. So I also need to convert milliliters to liters, and I know I have 700 milliliters, and I know that in 1 liter I have 1,000 milliliters. So I'm going to do 700 divided by 1,000. That equals 0.7. So I can do this number divided by 0.7, and that gives me a molarity, well, 0.3526 divided by 0.7 equals 0.5037 molar. I'm just using this. I also have no decimal there, but I mean it's multiple guess on the test. Okay, so next problem. A 0.6 liter sample of a 2.50 molar solution of potassium iodide is Ki, contains what mass of potassium iodide? So I have the same equation. I have 2.50 molar is equal to something over 0.6 liters. Well, I need to get this alone, so what I'm going to do is I'm going to multiply it by 0.6 on both sides. So I'm going to have 2.5 times 0.6. That's going to equal 1.5 moles of potassium iodide. So that's how many moles I have. But I need to find mass. So I need to look at my periodic table and find out what the mass of potassium iodide is. So I look at potassium. Potassium is 39. I look at iodine, and iodine is 127. So I have 39 plus 127. That equals 166 grams per mole. Well, if I have 1.5 moles, I need to get rid of moles. 1 mole is at the bottom, and I have 166 at the top, so I'm going to multiply it by 1.5. and I end up with 249 grams of potassium iodide. Last two problems. It says, how would you correctly prepare 127 milliliters of a 0.3 molar solution of copper 3 sulfate from a 2 molar solution of copper 2 sulfate. So again, I have no idea. So I'm going to go back and I'm making a solution. So solutions are solutions. So then, oh, there we go. So it says, this equation says the volume and molarity are going to be equal to volume and molarity. Oh, that's rather convenient. So all I have to do is make sure that my numbers match. So I have a 0.3 molar solution and I have 125 milliliters of it, and that's going to be equal to the 2 molar solution I want, but I don't know how much volume I need, so I'm going to divide both sides by 2 molar. So I'm going to do 0.3 times 125 divided by 2. So let's cancel that. I'm left with 18.75 milliliters. So there we go. Last problem. The last problem reads, a 22 milliliter sample of 12 molar sulfuric acid is diluted in a volume of 1,200 milliliters. What is the molarity of the diluted solution? So again, same equation. M1V1 equals M2V2. So